We are going to SEFU the big ugly formula VF squared equals VI squared plus 2AD. And we're going to consider both situations. One where the initial velocity of your moving object is 0. So you drop a rock from rest, or a car starts from rest, and you have VI is equal to 0. Let's take care of those first. If VI is equal to 0, then the formula becomes VF squared equals 2AD because the VI squared goes away. And this becomes pretty straightforward to SEFU. We're going to SEFU it for A. And to SEFU it for A, we're going to do that by dividing each side by 2D, because that's what I have extra with the A. So I have VF squared over 2D equals 2AD divided by 2D. And the 2's cancel and the D's cancel. And I end up with A equals VF squared over 2D. Okay, that's one. If I SEFU this in green for D, I do that by dividing each side by 2A. So I have VF squared divided by 2A equals 2AD divided by 2A. And the 2's cancel, the A's cancel, and I have D is equal to VF squared over 2A. Okay, there's a version for D and A if we are starting from rest with the initial velocity of 0. All right, if initial velocity is not 0, we'll do these one at a time. What if you have to SEFU for VI? All right, I'm just going to rewrite the formula here. If I have to SEFU for VI, I've got that by itself in its own term, but I have it added to the other term, 2AD. So I have to subtract that from each side. Minus 2AD, minus 2AD. And I'm going to have on the left VF squared minus 2AD is equal to VI squared. And that means that VI, I get by taking the square root of each side, and I get the square root of VF squared minus 2AD. I'm going to make a note here. I've seen the mistake in the past. Students have square rooted this, and they say, oh, I know the square root of VF. I'm going to write this in red because it's bad. They say, oh, I know the square root of 2F. I'm sorry, VF squared is VF. Let's see, minus square root of 2AD. This is not correct. You're taking the square root of the difference of these two numbers, the whole thing. And you can't just square root one of the terms and do what I just did, which is wrong. Boy, that was really well explained. But you have to leave it as the square root of VF squared minus 2AD. Okay. Next, I'm going to take that original equation and SEFU it for A and D. Need a bit more room. So here's the original equation. VF squared is VI squared plus 2AD. If I'm SEFUing for either A or D, I have to get this term by itself, which means I have to get the VI squared out of there. And I do that by subtracting VI squared minus VI squared. And I have VF squared minus VI squared equals 2AD. This is my launching point for SEFUing for either A or D, acceleration or displacement. And as much as I did earlier, if I have to solve for A, if I'm solving for A, I have to divide both sides by 2D. Because I've got A here, I've got to get rid of the 2 and the D. And so, rid of the circle. And so I divide each side by 2D. I give myself more board, and I get VF squared minus VI squared over 2D equals 2AD divided by 2D. The 2's cancel, the D's cancel, and I get acceleration equals VF squared minus VI squared over 2D. Likewise, if I'm taking this equation and solving it for D, it's a very similar procedure. I divide both sides by 2A. 2AD divided by 2A, the 2's cancel, the A's cancel, and I get D is equal to VF squared minus VI squared divided by 2A. We have it.